Today we're going to talk about the discriminant. And the discriminant is the idea of this formula, number of roots. What do we mean by roots? Yeah, x-intercepts. That's what roots are. So if we're going to talk about the different types of roots here, and we talked about this the other day, there are really three options. This option, which is option 1, we'll call it. How many roots are there in this one? Nothing. There are no roots in this option. There's option 2. That's right. Option 2 has 2 roots to it. It crosses the x-intercept twice. And what's the third option?
Only one.
Only one root. So, like this, where the vertex is touching. Okay, so that's our third. And I kind of crammed that all in there. But we've talked about this idea before. So there's really 3 idea of roots. So the discriminant allows us or helps us figure out how many roots there are. And I want to show you that the discriminant is this part of the quadratic formula, the b squared minus 4ac. Does anyone know, and actually first let's get into this idea, when finding the number of roots, when these are equal to certain numbers, it tells us which of the 3 situations we have. So the first situation, let's say, I'll do it in red here, when b squared minus 4ac equals a positive value, we have 2 roots. Okay. When b squared minus 4ac equals 0, we have 1 root. And when b squared minus 4ac equals a negative value, we have 0 roots. So, before we even go into this, why is this the case? And let's relate it back to the quadratic formula. If I have a positive value, okay, and we square root the positive value, how many answers do we get from it? Do we only get 1? We get 2, right? The square root of any positive value could be 6, could be 10. We're going to get 2 answers from it. Whatever it is, we'll get a positive and negative value. So 2.7 and positive 2.7. 10, positive 3 point something and negative 3 point something. We get 2 answers. So those 2 answers are what cause us to split the quadratic formula. Therefore, we'll end up with 2 roots. I'm going to go right to 0 roots. If our square root is a negative value, okay, why would we get 0 roots? Because we can't square root a negative value. So because we can't square root this negative value, there's nowhere to go. We have some parabola that does not cross the x-intercepts. That's our case number 1 that we drew up there. Okay? So either the vertex is above the x-intercept and it's facing upwards, or the vertex is below the x-intercept facing downwards. Okay? What about when it equals 0? Why would I only get 1 root? The root won't technically be 0. Okay, so what did I do to figure out this? The positive, I put it where? Under the square root, right? And I did the same with negative. What if we put 0 in there? What's the square root of 0? Is there a positive and a negative 0? Not for our case, right? So there's no positive, negative 0. Essentially, whatever this number is, you can add or subtract 0. It won't change it. So there isn't 2 roots. You're only going to end up with 1 answer in these cases. So anytime b minus 4ac is equal to 0, there's only 1 root. And that's our case number 3, where the vertex is directly on the x-intercept. Oops, wrong one. Yes. So we have 3 forms of the same quadratic. Okay? I'm pretty sure I completed the square properly here, but I'll double check it. The 3 forms we have are standard, factored, and vertex form. Now remember, the discriminant helps us find what? Our b squared minus 4ac. What does it help us find? Which is a number of roots, right? Number of x-intercepts. So, first of all, when we talk about this discriminant, the 4ACB, which of the three forms are we talking about? Which one is represented A, B, and C? Standard, right. Now, my question to you is, why is it only really important to have a discriminant for standard? For instance, in factor form, is it easy to see how many x-intercepts we have? Really easy to see how many x-intercepts we have. Why? Those are the two x-intercepts right there. We know what they are. They're -5 and +2. Very easy to see that there are two. How about in vertex form? Is it easy to see? It is. So we have to do a little thinking. Okay? First of all, which way does this parabola open? Up, right? This is positive. So we know it opens up. And where is the minimum value? Because this is the y value of the vertex. Is it below or above the x-intercept? Below. It's a negative value. So because it's a negative value, and I know it's a really funny looking value there. It's like -11 or -12 point something. Whatever it is, it's below, and we know that this opens upwards. Therefore, how many x-intercepts do we have? 2. So from vertex form, it is really easy. As long as we know which way it opens and we can tell where the y value of the vertex is, we can find the number of x-intercepts. It's standard form that by looking at it, by inspection, we can't really tell how many x-intercepts something has. So we're going to figure it out. We're going to take our values, our a value. What is our a value in this one? Yes, the coefficient in front, right? That should be an a, not an I. So here's our a value. What's our b value? Right, +3. And what's our c value? -10. Excellent. So let's plug those in. Our b value is 3, so we have 3 squared minus 4 times, what's our a value? 1. And what's our c value? Oops, sorry, I wrote the wrong number. -10. According to these forms here, factored in vertex, we should have 2 x-intercepts, so let's figure it out. What's 3 squared? 9. -4 times 1 times -10. Positive or negative? +40. What does it equal? 29, right? So if you just say number of roots, okay? So the number of roots is not 49. How many is it? Yeah. You can also you can put like a letter D here if you wanted to use that as a description, but because this is a positive value, how many roots do we have? 2 roots. Okay. So the discriminant told us, which we already knew from the factored and vertex form, that there are 2 roots involved in this question.